All right, in this video, we're going to take some notes on standard deviation. Yesterday, we got a good feel for how you do this by hand. We're going to put some notes in your notebook so you have reference material, and then we're going to talk about, just briefly, how to put it in your calculator. So standard deviation is often known by the lowercase Greek symbol sigma, which is that little 0 or O with a bit of a tail on it. And standard deviation is a measure of how dispersed a set of values is. So by dispersed, we mean how spread apart. If your standard deviation is a low value, then that means that your values are all pretty close to average. And another word we can use for average is the mean. So again, if you have a low standard deviation, that means there's not much dispersion in your data. They're all pretty centralized around the average. Now, if your standard deviation is a large number and you have a high standard deviation, that means that your values are spread out over a wide range. Again, low standard deviation, we could use this little curly Q, O, or 0, I don't know which one to call it. And that again is a lowercase sigma, Greek symbol, lowercase sigma. So let's put this to work. I'm going to give you 5 data, 3, 4, 7, 11, and 15. So that's our data. The first thing we need to do is find the average or the mean. That's often noted as X bar, an X with a bar over the top. X bar is the average. So to find the average, we're going to add them together. 3 plus 4 plus 7 plus 11 plus 15. And then we divide by the number of numbers. There's 5 members of our data set. I calculated that, and our average is 8. The next thing we do is calculate the deviation. So that means how far are we away from average? Well, our first data point, 3, is 5 below 8. 4 is 4 below 8. 7 is 1 below 8. 11 is 3 above 8. And 15 is 7 above 8. So my standard deviation, again, is how far are you away from the average? Then the next thing we do is we square the deviation. So -5 squared is 25, -4 squared is 16, 1 squared is 1, 3 squared is 9, and 7 squared is 49. Then what we'll do is we'll add all of these squared deviations. So 25 plus 16 plus 1 plus 9 plus 49 is equal to 100. So once we've found the sum of our squared deviations, then we can calculate the variance. And the variance is noted as lowercase sigma squared. I'm just going to call it sigma squared from here on out. Uppercase sigma, remember, is this, and we used that when we were looking for summation of an arithmetic or a geometric sequence. Okay, forget about that. So variance squared or lowercase sigma squared is going to be helping us find the variance. What we're going to do is we're going to take that number and divide it by the number of numbers minus 1. So our variance will be 100 over 4, or 25. So anyway, my symbols are kind of all over the place here. I'm going to erase this business because variance is noted as that symbol squared. So when you see that squared, you're thinking variance. And then the next thing we're going to do is calculate our standard deviation, which is just that symbol. And the standard deviation is the square root of the variance. So it's the square root of 25, which is just equal to 5. So our standard deviation is 5. So what does this mean? Well, write this statement down. What this means is that roughly, the data is about 5 units away from the mean. So we looked at that example of standard deviation when we did the Are You Smarter Than the Fifth Grader test. And that gives us an idea of what standard deviation means. And we're going to look at more examples with some real data sets tomorrow. So standard deviation roughly means the data is about 5 units away from the mean. All right, now underneath here, this is going to be the calculator steps that we'll follow. These are the calculator steps we'll follow. First of all, we're going to hit Stat. We're going to go over to Edit. We're going to choose number 1 where we need to enter the data in L1. So we'll enter the data in L1. Normally we enter a couple of columns of data, but here we're just listing one set of numbers to work with, so we'll only use L1. Then the next thing we'll do is we'll go back to Stat. We'll go over to Calc. So over 2 jumps to calculate, and then we're going to choose number 1, variance statistics, I think is what that stands for. So when we get to this window, we'll hit enter a few times. So we will hit enter a few times. And then we're going to look at, so here's my little eyeglasses. We're going to look at SX, and this is going to give us our sample standard deviation. Sample standard deviation. You'll also see where it gives us this business, but this will give us our population standard deviation. And in our case, since we're doing this with a very finite set of data points, we're going to always look at just the sample standard deviation, and we'll find that that is what we would get if we calculate it by hand. All right, so that's all I have to say about that. We'll get more practice, both doing it by hand, standard deviation by hand tomorrow, and using the calculator. All right, good work. I'll see you tomorrow.